Okay, I know my screen's going to look a little different for this lesson, but I wanted to show you some things on a online web page since I don't have a calculator available and some of you may not either. I went to arachnoid.com/polysolve/index.html, and this is a quadratic function, quadratic regression calculator. If you take a look at our first example, it asks us to take a set of data and first make a scatter plot of it and then find the equation of best fit, the quadratic equation of best fit. And what it's doing is calculating speed versus miles per gallon for a car traveling down the highway. And what I did was just copy the data there, and if I paste it into my data entry in this applet here, you'll see that it comes up with a graph down here, this blue line, that is sort of the quadratic function or the parabola that best fits the data. Each of the points up here in the data entry area, see for instance 3018, are points graphed here on the graph. Each one of these represents one of the points up here in the table that I gave it, and then the applet goes through and calculates what quadratic function best fits all of that data, so kind of forms an average from each of those points. If you actually plot that function and then ask the calculator to give you the equation, down on the bottom of the screen where you can't quite see, there's a results area, and in that results area it has a lot more accuracy than we really need, but what it basically says is negative 25 is our constant term, that 19 is our x coefficient, and that looks like 0.017 is our x squared coefficient. So we have 0.017x x squared plus 19x minus 25, and that's the equation for the polynomial or the parabola of best fit for the data that they gave us for the question. So that's the first part of the question solved there. Okay, we're back on our familiar chalkboard here. I took the information from the graph that we just got using that scatter plot tool that I just showed you, and I actually entered it into a graphing tool at an address www.desmos.com. They have a free online graphing calculator that I love. It does just amazing things, and you can play around a lot with it and see different ways that changing values in different quadratic functions or any polynomial function, how changing different numbers in those functions affects the graph of that function, and it does everything in real time. If you haven't seen it yet, I definitely recommend checking it out. So what I did was just plot that, hit projector mode, and then I did a screenshot and brought it here for us to take a look at on our blackboard. The last couple of things we need to do to finish up this question are find the speed that maximizes the miles per gallon, and then predict the miles per gallon of the car if we drive at 48 miles an hour. So here across the bottom we have our miles per hour, so our speed, and then up the side we have our miles per gallon. Oops, miles per gallon, sorry, not miles per hour that way. And then what we need to do here to find our maximum, we really just need to find the top of our parabola here, because as this goes up, our miles per gallon go up. So up here at the top of our parabola is where that is going to be maximized. We can see that looks like the maximum miles per gallon is just about 28. And at that point, at that maximum point, speed is 50, 55, so about 57 or 58 miles per hour. So the maximum efficiency, if you like, efficiency is at 57 or 58 miles per hour when we get about 28, give or take, miles per gallon. And then the last thing was to see what our miles per gallon should be based on our graph if we travel at 48 miles an hour. So here, this line here is 50. So this one next to it, somewhere over about here, would be 48. So we just travel along our graph in the other direction, and we can see that at 48 miles an hour, we should get, looks like about 27 and a half, 26 and a half, or 27 miles per gallon. So the last part of our question there, it looks like about 27 miles per gallon at 48 miles per hour. And you can see you can get some pretty accurate information from plotting a graph and then using some online tools actually performing the regression, which can otherwise be relatively difficult, is just a matter of typing in the points and hitting calculate. Gotta love the internet age.